Good afternoon. Welcome to the course Thermodynamics of Materials. Today we are into lecture 107 and 108. So today's topic, as I started yesterday and gave you this is the topic, that is the modified form of regular solution. We discussed regular solution and this is over. But there is some point that we should consider for the modification of the regular solution, because one of the criteria is normally not obeyed by the solutions. So, so, so this I will mention here, and accordingly there should be some modification in the relation. So this this we will actually establish today. So what is this? This topic, today's topic is modified form of the regular solution when the quadratic gamma I versus 1 minus xi composition relation is not valid. It's not valid over the entire composition. That is not available. That is not realized for the entire composition. No. So A is solvent, B is solute. Valid. What is the validity domain? Validity from xb is 0 to xb is 0.15 to 0.5 only. Typically, depending upon the system, that too depending upon the system. So this is so now that means it is not going to xb is 1, not entire composition. So this can be case perhaps to help you. If I can do this actually here. So you just see this. Just I am trying to show you here. I actually you can attempt to show this. So I am showing you here to verify what it means that the activity coefficient composition relationship does not obey or is not valid over the entire composition. Suppose I start with the original one, the starting one rather, activity of B versus XB, as you know, 0 to 1. This is, and you recall that this is the activity composition relation we know very well, that is the Raoult's law line, a reference. So this is suppose our deviation, real solution is like this, as we know. So this is the activity B versus composition. Now this is obviously A and this is obviously B. Now you actually present now gamma versus composition, which is our interest. Right? How you get gamma? Gamma B you all know. Just this is activity B versus XB. This is the actual line is this. Okay. This is okay. So gamma B is obtained as the ratio of activity B over XB, and this is plotted against the XB. Suppose 0 to 1 again. This is A, this is your B, and suppose this looks like this. Yes. This is the curve. This is the gamma versus, this is gamma, this is the gamma B versus XB. And this is now today, this curve actually, I see, this is gamma B versus XB, which is the equation that we propose for gamma B against composition is valid up to this point. This point is what? XB, as I have written here, XB is a range 0.15 to 0.5, depending upon system, okay, roughly. So this is the domain where the relation that we give is just describes this part up to this concentration of the solute. For this, there should be another equation, and like this, okay. So since we are considering B as the solute, so we are interested here. So this is our gamma B. Similarly, if you actually want to draw the A is the solute. A is the solute is here. I'm sorry, A is the solvent. I'm very sorry, solvent. Whose gamma B is what? 0 to 1. 0 to 1. 0 to 1. Actually, this should be 0 to 1. Sorry. 0 to 1, and this is this curve 0 to 1. 0 to 1. So what is the gamma A? Gamma A will be like this. This is gamma B. This is gamma A. This is gamma A. Okay. So gamma B, gamma A. This is you can give here gamma A 0, 0 to 1. 0 to 1. Okay. 0 to 1. Okay. Now this is what? This is what? Gamma B at XB is 0. So this is known as gamma B 0. That we will use gamma B 0, and here you see gamma A. This is also actually, this should be actually gamma A 0, but anyway, we have to consider that validity of the relation that has been proposed in Margules will be valid here for B as well as for A. That means beyond this domain, this equation don't fit. For this domain, we must have other equation. So, but up to this concentration, we can consider that this relation, the Margule relation, will be valid. Will be valid. So accordingly, we will proceed. So start like last time. So you consider this, okay? That you focus on this part. This is for A. Gamma A is 1. Here 1, gamma is 1 here. Gradually decreases, and we will consider up to this point. And here gamma B is gamma B 0, gradually increases. at this point. So let us see. Let us see modified as before. As before, as in the original case, as before, we write ln gamma a. What? Tell me. Gamma a is what? Alpha 0 plus Margules. Margules actually relation. Alpha 1 xb plus half alpha 2 xp square, and I am not write cube because we have already considered this quadratic. Quadratic, the only new thing that has been injected here today, that has been introduced, new thing is this, that is that this equation will be valid up to just this constant. So this is the validity regime. Let me write. This is, focus on this. What is this? This is the validity regime. Validity regime, validity domain rather, validity domain. Validity domain, domain for ln gamma b versus xa and ln gamma a versus xb of the modified xb relation of the modified regular solution. Regular solution. So this is the modification, and this is very practical. This is very, because it will be tall order to expect this equation will be valid for the entire composition. This whole curve will represent this. A segment of this curve will represent this. Or similarly, let me write another one also. And what is ln gamma b? Is beta 0 plus beta 1 xa plus half beta 2 x square, like last time, exactly like last time. Okay, very good. Achha. Achha, here I should have made a comment actually. Comment. Achha, call this equation 1. Okay, I write this. Write this here. Okay, is. Achha, note here. Note here. Note when xb is 0. xb is 0. Okay, no problem. xb 0 is the domain. Okay, xb 0. When xb is 0, what happens in the domain? Xb is 0. We know what is this. Xa is 1, and we know gamma A is obviously when it is pure, gamma A is 1, and as we see here also. This is B, this is A. B, A, gamma A is 1. Okay, so gamma is 1 here. Okay, this is. So what is ln gamma A? Ln gamma A is then what? 0. If we see this, ln gamma is 0, xb 0. What does it mean? Alpha 0 is 0. This leads to this leads to alpha 0 is 0. So please note this part. Please note this part. So that means alpha 0 can be deleted, can be omitted. So alpha 1 xb plus half alpha 2 xb square. Okay, it is better. It has been clumsy actually. It has been clumsy. So let me write once more. Sorry. Once more. Is what? Right? Alpha 0 is 0. So it becomes, it is simplified. Alpha 1 xb plus half alpha 2 xb square. This is like last time. This is like last time. Okay. Now what about ln gamma b? And ln gamma b is what? Tell me. Beta 0 plus beta 1 xa plus half beta 2 xa square. Okay. This is, so this, call this equation 1, call this equation 2. This is this 2. Okay. Now what we will do this? Okay. Equation 2. Using the Gibbs dual equation. What is the Gibbs dual? Pertinent xa dln gamma a plus xb dln gamma b is 0. That is the Gibbs dual. If we apply this, do this, we get, using this we get what? Xa dln gamma a. So start here, xa dln gamma. So d of this alpha 1 dxb plus xa dln gamma a. Alpha 1 dxb plus alpha 2 xb dxb. xb square 2xb dxb, 2 and half cancel. So is what? Minus xb dln gamma b. I am taking this term minus on the other side. Minus xb dln gamma b. Right, this dln gamma b. This is the gamma b. So it is what? This is a constant term. So no. So it will not be counted. Beta 1 dxa, beta 1 dxa plus beta 2 beta 2 xa dxa, xa dxa, beta 2 dxa. Now noting dxb is minus dxa and xa plus xb is 1 means what? What is xb is 1 minus xa. So from this you get this also. We will use this two relation here. First of all, you see dxb is minus dxa. So dxb and minus dxa cancel out, leaving behind what? And also, actually leaving behind what I am saying, I'm explaining xa. Alpha 1 xa, write this term. Alpha 1 xa is a coefficient of xa. Then what you have here? Next is plus alpha 2 xa times xb. xa times xb, I will write xb in terms of xa. Xb in terms of xa, because to write this equation in terms of xa throughout. So that will help me to compare the coefficient of xa, x square, constant, etc. So go ahead, xa, xb. So is what? This minus is already absorbed from the minus dxa. So what remains here? Xb. Xb means you don't want to write xb. You write both sides in terms of xa. 1 minus xa, and you write what? Beta 1 dx out beta plus beta 2 xa. Okay, this. So write, so clarify this, or we can write noting we have. Okay, you understand this? Okay. So or what right? Alpha 1 xa plus alpha alpha 2 xa first term and alpha xa. So they make alpha 1 plus alpha 2 xa. That is the coefficient of xa on the left hand side, plus or rather minus alpha 2 xa squared. This is about the left hand side. Right hand side, you see, we have a beta 1, a constant term, alone, no xa accompanying it. So beta 1 plus beta 2 xa and minus beta 1 xa. So what you will get this? Beta 2 minus beta 1 xa, and last term is what? Last term is minus beta 2 xa squared. So give a barrier here. So this is. Now comparing coefficient like last time, comparing coefficient of constant term, xa and xa square between the left hand side and right hand side expressions. Actually, right hand side expressions. What we get? Tell me constant term. What is the constant term on the right hand side? Beta 1. Left hand side none. So beta 1 is 0. Compare the xa term. Xa. Compare xa. What you have on the left hand side? Alpha 1 plus alpha 2. And the right hand side, beta 2 minus beta 1. Beta 2 minus beta 1. Beta 1 is 0. Is beta 2. Xa. Minus beta 1 is correct. Okay. And xa square, we have what? Minus alpha 2 is minus alpha left hand side and right hand side minus beta 2. So this gives you, or alpha 2 is beta 2. This we get. Now from this you get what? From this what you get? Alpha 1 plus alpha 2 is beta 2, and beta 2 incidentally is alpha 2. So what you get? Alpha 2 cancel, leads to alpha 1 is 0. So what we get? Summary, what we get? Alpha 1 is beta 1. Sorry, alpha 1 is beta 1 is 0, and what else? Alpha 2 is beta 2. This is the relations obtained from this comparison of coefficient alpha 1, and we will use this into the original equations. Okay, so this is this alpha. So alpha 2 is beta 2. So let us go on. Okay, so now from equation 1, we write this, substitute this results into this. Ln gamma A is what? Tell me. Ln gamma A is what? Tell me. Alpha 1 is 0, so this is out. Half alpha 2 half alpha 2 xb square. And from equation 2, how to get here ln gamma, this is a 2. Ln gamma B is what? Beta 0. Beta 0 plus beta 1 except beta 1 is 0. Beta 0 plus beta 1 is 0, so this term drops away and you get half beta 2. Half beta 2 is, what is beta 2? Is alpha 2, expressed in terms of alpha 2. Okay, instead of having alpha 2, beta 2, which are equal, so expressed in terms of any one of them, say alpha 2. Half alpha 2, what you get there? X square. See here, see here, see here, half, well, here. Half beta 2 means alpha 2, x square. So ln gamma is, so okay. Achha, give a star mark here. Now remove this top. So here star. What is this? Letting, like last time, letting half alpha 2 as alpha, as before, as in the regular case, okay, as before. What you have? Let us write ln gamma A, ln gamma A is alpha xb square, ln gamma B, beta 0 plus half alpha 2 means alpha x square, alpha x square. Now you see here, so now when xa is 0, xa is 0, oh sorry, I'm very sorry, xb, xa is 1, I'm very sorry, xa is 1, no. Now what is this? Xb is 0, then gamma B is beta 0 plus alpha x square. When xa is 1, I'm very sorry. Let us. I was actually on the wrong direction. Xa is 1 because this is the domain. This is the domain. So xa is 1 is included. Okay. Xb is 0 up to this means xb is 0 means xa is 1. These are included. When xa is 1, that is tell me xb is 0, gamma b becomes what? Xb is 0, gamma b, xb 0, gamma b at xb is 0, gamma b is gamma b 0. If you substitute this information here, that so ln gamma b, which becomes ln gamma b 0, you see, for when x is 1, is beta 0 plus alpha. Take a look. X is 1, so alpha 0. Ln gamma b becomes gamma b 0. Or what is your beta 0 is what? Is beta 0 what? Try to find out beta 0. Ln gamma b 0 minus alpha. Beta 0. Okay. So this, if we apply this, if we use this one into this equation, you get hence hence ln gamma b from this, hence ln gamma b is what? Beta 0, instead of beta 0, what you write? Ln gamma b 0 minus alpha plus alpha x square. That's it. So I am actually writing, okay, also, so just write this together. So what is this? So I am writing this 1 to ln, again write ln gamma s. So the final relations are what? Tell me, ln gamma a is what? Top alpha xp square. Ln gamma b is ln gamma b 0 minus alpha plus alpha x square. Call this equation 3, call this equation 4. 1, 2 already there, so we don't need them anymore because we have got the more developed relationship and okay, which is coming from this initial ones, but these are the final forms. So this retain this 3 and 4. Now 3 and 4 is okay. Ln gamma by 0 is alpha. These two equations, incidentally, these two equations are known as Darken's quadratic formalism. Darken quadratic formalism. So this is a very popular term, but we have proved this actually in our own way, starting from the first principle, starting from the Margules and giving the conditions for this limited limited and condition of this of the gamma b versus xb relation will limited extent, that is up to mole fraction up to this range. So under this condition, we starting from Margules, we have actually adapted this. Only thing you see, what is the regular solution equation? Please follow. This was as before. This was also obtained in the regular solution. But in the regular solution, ln gamma b was alpha x square. So what is the modification? Ln gamma b 0 minus alpha added. Because the equations, the starting equations, starting quadratic relation, static equations, okay, what is Margulis equations, were considered to be obeyed up to a certain concentration of the solute, namely B. Certain concentration, not throughout the not over the entire composition from xb is 0 to xb1. So since this modification is there, so equation is this is showing up here. Now I will show you that if we actually again consider this that the equation, the Margulis equation, the starting equation, gamma versus composition relation, that is valid over the entire composition. Entire again see, then you will see you will return to the regular solution. How? See this actually I will show. So comment. So comment here. Comment. Comment. Comment is what? What I tell you that I now actually I open up this validity range like the original regular solution. That it is valid over the entire composition. If I apply this, we will see the original regular solution will return. Comment when the gamma when the gamma when the gamma I versus 1 minus xi 1 relation xi relation is valid over the entire composition range, entire composition range, composition range. We have what? Entire composition range. What we have? Up to xb is 1. Then gamma b, we have gamma b is 1 at xb is 1. No doubt. Because this up to xb is up to xb. Up to xb is 1. Then gamma b at xb is 1, activity is 1, gamma b is 1. So it's clear. So then what you get? Gamma b is 1 at xb is 1. If we apply this xb, that is when xb is 1, what is xa? Xa is 0. Apply this into this one. Apply this into the fourth. So in the fourth, okay. And from equation 4, we get what? We get what? We get what? From equation 4, we remove this. We remove this also. Unnecessary. Only keep this diagram. And from equation 4, what you get? ln gamma is 1 means ln 1 is 0. And x is 0 means this is 0. So what remains? ln gamma b 0 minus alpha is 0. That is hence what is the relation? Becomes ln gamma b is alpha x square. Same equation as the regular solution. So it was modification, but now it returns to this when we consider that the validity is over the entire composition. Gamma versus composition relationship, which is Margulis relationship. Initially, we started from that point. So we return this, and already it is gamma is already there in the relation. So what should I comment there? This is these together. So this together with what? This one ln gamma a is alpha xb square. This together with ln, which is equation 3, which is equation 3. Equation 3. Equation 3 describe the regular wave solution behavior. Describe the regular solution behavior as established before. As established before. We already established this now. So remember, this is the regular solution, this is the modified regular solution. And while it is changing here, this ln gamma has not changed. Gamma is alpha xb square still retained. Only gamma b has got this extra term, ln gamma b 0 minus alpha, in addition to alpha x square, which should have been there, but this is the additional term. This is because of the modification. Modification, why? Again, I say repeat, because this equation, this gamma versus composition relation, the Margulis relation, what is gamma B versus composition or gamma A versus composition relation is considered to be valid over the limited solute range. What is that? XB is 0 to XB is 0.15 to 0.5 depending upon the system. So with this, last is what? Some examples of regular solution or modified regular solution behavior. Just I should give you. Some okay, this is as established before. You did this behavior, it's okay. Some examples of the regular solution or modified regular solution are what is this? Are tin lead system. Binary I am talking of tin lead, tin thallium, okay, iron silicon, mercury potassium, magnesium, bismuth. So with this, we have completed the modified regular solution. Okay, and regular solution already completed. Today we have completed the modified regular solution completed. But we will try to establish this modified regular solution. These equations, verily these two equations. Alternative method, that is using Maclaurin's series expansion. That is the alternative, because this is very interesting. This I will show you because I will explain you why I am taking up this. So let me remove all this, okay, over. So I tell you, let me tell you a few words, and okay, and then I will remove this also because I start fresh. What is currently we are discussing is we will discuss rather is what that we will establish this. Oh, this equations actually I have removed this. These equations I write at the bottom maybe. What relation I get? Modified ln gamma a is alpha xb square ln gamma b is ln gamma ln I save somewhere here. Maybe I will save here. Save here where you have saved. I will save here. Save here. Ln gamma a is alpha xb square. Ln gamma b is ln gamma b 0 minus alpha plus alpha x square. This is the modified regular solution. Modified regular solution, which is known as Darken's quadratic formalism. Darken's quadratic formalism. Also, I said this. So this is anyway. This you remember this. But we have Darken proved in a different way. But we have proved from the first principle, and we have proved our own way. Okay. So this is also an independent proof. So these are the examples I have said. So let us start. I tell you the story. Let me remove this. Let me remove this. No more, because I next topic. This I okay. This I say here because we also arrive at this point. Alternative method, modified, not just regular solution. Not the ordinary regular solution. Not the regular solution. Okay, just this ordinary regular solution. This modified. This is practical. This is practical because I said that the validity cannot be over the entire composition. This relationship cannot describe the curve over the entire composition. The relationship cannot describe the activity coefficient versus composition curve over the entire over the entire range, limited range. So practical. This is practical. This is also known as this. Okay. This is also known as Darken's quadratic formalism. I am not writing here. I have already said this. But start. What is the topic now? I will explain you. What is the topic? An alternative method. An alternative method with the help of Maclaurin's series, Maclaurin series expansion to arrive at the same modified regular solution, same modified regular solution some variable regular solution relation between gamma I versus 1 minus xi, as you have seen, between for the binary system A B where A is solvent, B is solute. This is the topic currently. Why I have taken it, I tell you, this is my personal experience. I found in textbooks and teachers, maybe instructors, what I found that when it comes to regular solution, they are referring to Margulis equation. It's very interesting. Margulis equation that we have discussed and established regular solution. And the moment they are coming to the dilute solution thermodynamics, thermodynamics of dilute solution, they started using Maclaurin series or Taylor series. Sometimes they say Taylor, a special form of Taylor series is Maclaurin series. They start using Taylor series or Taylor theorem. I could not follow why actually suddenly they dropped the idea of Margulis. That is also infinite series, goes dot 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 several terms like Margulis. But they are not referring back to Margulis anymore. Margulis is limited to regular solution derivation. And dilute solution thermodynamics uses Maclaurin's series expansion. That means they are not using Margulis equation in the dilute solution derivation. They are not using Margulis equation in the dilute solution thermodynamics of dilute solution dilute solution derivations. Similarly, they are not using for the regular solution proof, regular solution derivation, the Maclaurin series. That means they are not using Maclaurin series for the regular solution derivation, and they are not using Margulis equation for the dilute solution thermodynamics derivation. Very interesting. That's why I will show you here that with what you achieve with the Margulis modifier. Remember, this is starting is Margulis, then modifications are there, okay, restriction, etc. So we have already proved, and we will also prove with the help of Maclaurin. Then we will be very satisfied that this can be proved both ways. I have never seen any book where actually this regular solution has been proved with the help of Maclaurin. Today we will do this. Modified regular will be proved with the help of Maclaurin. Neither I have said any time regular solution is proved with the help of Maclaurin. Or conversely, dilute solution thermodynamics is proved by Margulis equation. So they are interchangeable. They can be, that is, both are series. So there should be link there. Start how I am doing, okay? Start this. This is the background. So I have taken up this, okay? Maclaurin's. This is the end point, remember, we'll reach here. But with some additional okay, relation or additional insight we'll get from this. Let us follow. Maclaurin's series expansion. I am starting here. Ln gamma b is a function of xp. This is a calculus based relation. Ln gamma, this is Maclaurin's. Then function c, or what you can write, or let me or ln gamma b at xb is xp is what? Ln gamma b. This is a Maclaurin series. Ln gamma b by want to get at xb xb, how we can get from this, refer to the xb is 0 and there will be additional terms that will equate the left hand side. Ln gamma b at xb is 0, then first derivative del ln gamma b by del xb again at xb is 0 plus the second one half factorial to second order derivative del 2 ln gamma b by dxb cubed, again xb is 0 and I must write the last one, the third one, at least third one, although I will actually curtail this, we will actually eliminate this or you will ignore this, like last time, okay, only quadratic. Anyway, but for the sake of generalization, write this 1 by factorial 3 del q ln gamma b over del x b cubed. Again, this derivative taken at xb is 0. This is very interesting observation from Maclaurin series expansion. You will get ln b at xb is x. At xb is xb, what is the ln gamma b? This plus, of course, plus, because this is an infinite series. 1 by factorial 4 like this, and del 4 like this. So we'll actually at the very beginning we'll consider this only up to quadratic terms. Oh, I am very sorry, I missed one point. Interesting. There is xb here. This times xb and likewise this times xb square. I am very sorry. Plus this, and this time this should get an xb cube and dot series, infinite series. Okay. So up to quadratic term means this point. So this let us reach considering like last time, considering ln gamma b can be well represented by up to the quadratic term as before. We also did this in case of regular solution, marbles as before, and here also only quadratic. This name is quadratic solution model, quadratic model. Name is quadratic. Okay, anyway, what is this? As before, and designating this ln gamma b one by one, term by term. Ln gamma b xb is 0. You know very well what is this. This is known as xb. Ln xb gamma b at xb is 0, known as gamma b 0. So ln gamma b 0, but we will give a symbol here beta 0. This is beta 0, and right here it is applicable to AB binary. AB binary to the system AB, to the system AB. AB. Second is what? This one, del ln gamma b over del xb at xb is 0. Remember these derivatives. See what is this? You know perhaps Maclaurin series mathematical exercise. Ln gamma b xb. Suppose this is a car. Listen what it says. At this point you are interested. You are interested to get ln gamma b at xb. xb is xb. Then what it says? What it says, take ln gamma b at xb, this xb is 0. Take gamma b at xb is 0. Then take dln gamma b dxb at xb. So take the derivative at xb is 0 times xb. Next, take the second derivative, the first derivative, and then second derivative at xb is 0. Okay, this actually you have to plot actually dln gamma b dxb, then okay, at different values, then xb. So if you have this value, that means this value will be obtained. These value will be obtained by referring to the values obtained at xb is 0. So all xb is 0. This is Maclaurin's equation. Okay, Maclaurin series expansion. So anyway, so accordingly, let us see. Is what? This is what? This is, I'm very sorry. Oh, this is known as, this is a symbol, very important, very important in case of solution thermodynamics and dilute solution thermodynamics, still making problems. All this EBB, interaction coefficient. This is known as EBB is, let us give a symbol beta 1. So this call this beta 1. Okay. So I have written here, this is called beta 0. Shall I write here? This is beta 0. In addition, I am writing beta 0. This is beta 1. And likewise, this is beta 2. Beta 2. This I will ignore. Okay. So okay. So this has been ignored. Okay. This has been ignored. Okay. Ignored. Because it is well represented by quadratic terms. So this is okay. EBB. This is beta 1 is the name is, this is name is what? Beta 1. EBB is known as, very important, for solving still making problems and okay, and are making problems. EBB known as, and okay, other chemical metallurgy problems, okay, solution problems, known as what? It is known as self interaction coefficient. Self interaction coefficient. And this also and applicable to the system AB. Again AB, because we are considering binary system. But I am writing this for some reason. Because sometimes you will see it is not applicable to AB. I will explain this soon. AB. But here all AB, all binary. Last is what? Del 2 ln gamma b by dxb square. Again, the derivative taken at xb is 0. Okay. And another thing is this. Suppose this is ln gamma b versus xb, and you have an equation. Suppose you have an equation. This is a curve. There is a corresponding equation. Then you take the derivative, first derivative, second derivative, third derivative, fourth derivative. Maybe sooner or later this will be constant and the derivative will be 0. So automatically the higher terms will be removed. Okay, will be 0 and should be discarded. So what is this? What is this? This is actually, I should write, is beta 2. Is beta 2. So clear? Beta 0, beta 1, beta 2. This is beta 2. This is what? This is second order derivative. Second order derivative. Second order derivative and applicable to the system. Again I am writing, and applicable to the system AB. Okay. this given. Why I tell you what. This is a binary system. There is just in passing note. I will in passing note. Note note in the case of ternary system. Case of ternary system ABC will come across what? What is this? The term EBC. Follow? Since this will be what I am giving you beforehand, but we'll discuss this later. But you try to understand this. Why it is EBC is what is the definition? E ln gamma B. Again, through Maclaurin's expansion. D ln gamma B. This I'll show you. Maybe a few classes later. Okay. 1 or 2 classes later. By dxc at this is very interesting. Xb all should be at the 0. Okay. This is actually what is the name of this? This is self interaction coefficient. This is known as EBC is known as self because BB self. This is called ternary interaction coefficient will come later. And also this will be applicable to which system? Now we understand to the ternary system ABC. When we consider ternary, some will be binary. Some will be binary system like these two terms. But some will be ternary. So binary combination. But when it is binary, it's all binary. AB. So this is the reason why I mentioned this. So actually I want to remove this because I have to move on. So what you get, let us write this. So what you get. So we have what after this designations we have what? Write this. I'll remove this soon. We have what? Ln, right, nicely right. Ln gamma B at xb means that is our desired composition. Ln gamma B is what? Tell me. Beta 0 plus beta 1 xb plus half beta 2 xb square. Okay. Quadratic up to quadratic. And ln gamma A is what? Tell me. Acha, very good. This is okay. This equation, I have given some name to this equations. I have not yet call this. What is the equation 1? Call this equation 1. Call this equation 1. Can I remove this? This is later on, but I introduce you just in case you have some difficulty about understanding this, or you cannot get used to this. Okay, but this will be discussed later, and very good. Okay, so similar things will be coming later. So this is the very beginning, modest beginning, I would say. This now similarly. Ln gamma A is what? Ln gamma A is right function of x. You write again is like this is function of x, or like ln gamma A xa is xa is what? Xa is xa. Ln gamma A is xa is ln gamma A xa is 0 plus del ln gamma A over del xa at xa is 0 plus half delta 2 ln gamma A over del x square this value taken at x is 0. Again, I made a mistake here. It will be multiplied by x here, multiply x and multiplied by x square. Okay, x square. This is okay. Now, okay. Now again designating this you call this is beta 0. Call it alpha 0. Call it alpha 1. Call it alpha 2. So write this designating. We write this ln gamma a at x is 0 quickly. X is 0 is known as ln gamma a 0. Call it alpha 0. Alpha 0. Del ln gamma a by del x a at x is 0. X is 0. Call it alpha 1. This is not interaction coefficient, okay, because this is about solute. This is a solvent. Alpha A is the solvent, B is the solute. A is solvent, B is solute. So alpha 1 and del 2 ln gamma A by del x square at x at x is 0. X is 0. What is alpha 2? As I have already given here, alpha 0, alpha 1, alpha 2. If you have this, can I remove this first line? I can very easily remove. Perhaps. This we have already. The beta is an important issue. Write somewhere. Since beta is I will remove this. I will remove this. I remove this also. This also. Let us see how much. This also. So let us see what we get from this. After this ln, so what we get ln gamma a, we have this designating, we have what we have. Tell me ln gamma a, at x is x means ln gamma a is what? Alpha 0 plus alpha 1 x a plus half alpha 2 x square. I think this is equation 1, this is equation 2. This is equation 1 and this is equation 2. It is important, one thing you have to note here. It is important. Achha, let me try another. It is important to note here that alpha 0 is ln gamma 0. Alpha 0 is ln gamma a 0 is a hypothetical quantity. Hypothetical quantity. Important note here that hypothetical quantity. Why? See, gamma a This domain is what? This domain, as we already know, this domain is on the entire composition. No, the validity of this relation is not over the entire composition, but up to a limited concentration of the solute. So that means what? That means what is the limit? Say xb is 0 to xb is 0.15. Say for example, a 0.1. Say xb is 0 to xb is 0.1. Then what is the corresponding x? Say x is 1 to 0.9. So how will, if it is that domain, it is restricted. So ln gamma at x is 0, how should we get? At x is 0, there it is not applicable. When gamma x is 0 means A is solute, B is solvent. So this value, this is actually not in the applicability domain. That I showed the applicability domain in the solute. xb is 0 to 0.15 to 0.5, not beyond. Not up to xb is 1 or x is 0. So x is 0 is not possible. So but how shall we get this? We extrapolate whatever x is valid over this. What is the concentration? I said x is 1 and corresponding, suppose 0.15, xb is 0.15, that is 0.85. So x is 0.85 to 0.1. The curve that we get, x 0.5, we just extrapolate to x is 0, this value gamma, this gamma here, x is 0. We have to extrapolate this curve, theoretical extrapolate, hypothetical value, x is 0, and this is actually x is 1, and this is the domain, validity domain. So how should we get this? So you are going to beyond this. In this zone, x is okay, xb is okay, xb is x is what I wrote here. X is 1. I'm sorry. X is 1. I'm very sorry. X is 1 and x is 0. X is 0 and x is 1 means xb is 0. X is 0 and this is xb is 0.15. Say 0.15 means x is what? 0.85. So x is applicable. The validity domain is x is 0.85. Oh, this time this is very. This is validity domain is this, as I told you. This is actually the gamma A. X is, I am showing you gamma A, x is 1 and x is 0. So this is the curve. This part of the curve is relevant. And here also remember this was for xb. This is xb. This is xa. Here valid. But xa is 0. Not valid because what is the xb? Xb is 1. Xa is 1 means xb is 0. And this is what xb is, as we know, 0.15 to 0.50. If it is 0.15 to 0.150, what is the xa corresponding xa? Xa is 0.85 to xa is 0.5. Not xa is 0. So not validity. So how do you get this value? Only through mathematically extrapolate this behavior. Extrapolate this behavior of xa to this. That's why it is called hypothetical quantity. This is not xa is 0. The way we write gamma b0, this is solute. Solute is applicable. Gamma b0 is for solute. B is the solute. When xb is 0, solute. But xa is 0. Xa is not solute. It is the solvent. And it has an equation that is not in the if there is an equation that is not described by this relation, because it has already considered the behavior is shown, this relationship are valid over a limited concentration range of the solute Xb and corresponding value of X. So Xb will not go to 1, neither Xa will not go to 0, or go down to 0. Xa will not increase, go up to 1, Xa will not go down to 0. So hypothetical. Let us move on. Hypothetical quantity is a hypothetical quantity because the because it is a hypothetical quantity because the validity regime which extends from Xb is 0 to, as I am repeatedly saying this, to Xb is 0.15 to 0.5 depending upon the system, regime which extends from the depending on system regime of the expression of validity regime of the expression, validity regime of the expression ln gamma a, of the expression of ln gamma a This is 1 and this is 2. Okay, I'll write together later on. Okay, let me finish this. Expression of ln gamma a does not include the concentration Xa is 0. Concentration Xa is 0. Include the concentration Xa is 0. This hypothetical value is obtained by how? Obtained by graphical extrapolation. Graphical extrapolation by graphical extrapolation to Xa is 0. That is Xb is 1. Similarly, these terms, all are Xa is 0 means hypothetical. You have to extend hypothetically. Similarly, the terms, what are the terms? Similarly, the terms alpha 1 and alpha 2. This is about alpha 0. I talked about alpha 0. Similarly, alpha 1 and alpha 2 terms alpha 1 and alpha 2 are also hypothetical quantities are also hypothetical quantities. Are also hypothetical quantities. Even so, interestingly, very fortunate, even so, these hypothetical values even so these hypothetical values are can be determined. What are the names, right? Alpha 0, alpha 1, alpha 2, alpha 2 and alpha 2 will subsequently be shown to be related to the real values, real values. The real values like what? Like beta 1, like beta 1, which is that is E B B, like beta 1, which is nothing but self interaction coefficient beta 1. Already I've said this. So this is very interesting that even the hypothetical this will be related. That means later on you will see alpha 0, alpha 1, alpha 2 all will be expressed in terms of beta 1, and we will have no problems. Okay, no problem. So we have to proceed now. Okay. So I actually want to remove this, clarify, clear up this. Sorry, equation 1 must be saved because this is actually let me write it on top. Ln gamma b, ln gamma b is what? Beta 0. Save this here. Beta 0 plus beta 1. Tell me xb plus b half beta 2 xb square. Fantastic. Okay. Ln gamma b beta 2 ln beta 2 x square. Call it equation 1. Just save these two and note here only one very important one. Note this will be all along required. What is that? Like this, gentlemen. This one. Beta 1 is epsilon EBB. Note that. Note this equation I said. Not there separately. But let me remove this. Beta 1 separately. Note what is beta 1? Very important. Expressing term is E B B. Only this. Here Ajay. Beta 1 is E B B. Only this I saved only. This I saved only. Okay. Only this I saved. Beta 1 is E B B. This I saved. And this rest is, let us remove all this. All. Keep this. We'll arrive here. Proceed now. Given this 1 and 2, you know what you will do, you know very well, we will apply Gibbs equation. Okay? So we have this, it is what to do. Now one thing before this, now because one thing here follow, here validity includes xa is 1, like xb is 0, xa is 1. So when xa is 1, what is the gamma a? Everyone knows 1. Xa is 1, activity is 1, gamma is 1. Gamma is 1. So because when oh sorry, because when xa is 1, gamma a becomes 1. X is 1, activity a is 1, and gamma a becomes 1. Then what you have? Ln gamma a, ln 1, 0. X's are xa1, xa1. So what is the relation you get? Becomes 1. This we get what? Here alpha 0. This gives us alpha 0. X is 1 means alpha 1 plus half alpha 2 is what? Ln gamma a. Gamma a becomes 1. Ln gamma is ln 1 is 0. This is another equation that will be helpful to arrive at the quite a bit. Please actually let me have a new pen. Just wait a bit. Actually, I will get 3 equations, then I will move on in the same way. Gibbs Duhem equation, then you know very well, I will equate the coefficients of xa square and the constant term, and then we will actually reach at this place with some correlation, with some very useful correlations. Let us start with this pen. So let me write this phrase: alpha 0 plus alpha 1 plus half alpha 2 is 0. This is called this equation 3. 1, 2, 3. One thing you note, very interesting and you note that Margules what? When you express ln gamma b in terms of xa square, recall ln gamma b was beta 0 plus beta 1 xa plus half beta 2 xa square, and ln gamma was what? Alpha 0 plus alpha 1 xb plus half alpha 2 xb square. So this is the difference between the what is this called, Margules relation, and the Maclaurin series expansion. No problem. But anyway, alpha xa and xb are interrelated. Xa plus xb is 1. So no problem. But you may remember this. Anytime you forget which way, because this actually work with this first derivative, second derivative, etc. So you will easily follow this. Okay. But remember, there is a contrast. This is gamma b the XA terms, XA, in gamma B, XA, or gamma A, gamma B, XB, gamma B, XB in molecules. But here gamma B contains XB, there gamma B contains XA, and gamma A contains XB, here gamma A contains XA. But all the same, you will see XA and XB interrelated, XA plus XB is 1, we will actually finally arrive here. So no problem. This is just in passing, you note that, to remember that how they look at differently at the initial stage. Later on you will see we will arrive here. Okay. So when okay, start with a new pen, and actually when and because X is 1. Anyway, this now apply the Gibbs dual equation. Gibbs dual equation. So it is applying the equation. What is that? You know, Gibbs dual equation XA dln gamma A plus XB dln gamma B is 0. We get a start from here. XA, what is dln gamma? You are used to this. This is third time I am doing. Dln gamma A, alpha 0 is a constant. So what you have here? You have alpha A dxa, alpha 1 dxa plus alpha 2 xa dxa as before. Gives to m again used here. Okay, is what? Minus xb dln gamma b minus xb dln gamma b. Quickly do this. Beta 1 dxb plus beta 2 xb dxb. Okay, this again noting what do you note? Tell me. Dxa is minus dxb, and you express in terms of x's all. So and xb is express xb in terms of and dxa is minus dxb and right, and if xb should be written in terms of xa, if we use this to noting, we have what we have, tell me. So dxa, follow, dxa is minus dxb, dxa minus dxb, dxb cancel. What? Start. Alpha 1 xa. Achha, you have what? Alpha 1 xa, and you have here alpha 2 xa. So alpha 1, alpha, this is quickly alpha 1 plus alpha 2 xa, left hand side xa. What else you have? Alpha 1 xa plus alpha 2, oh no, I am very sorry, alpha 1 xa अच्छा, alpha 1 x plus alpha 2 x square. Left hand side, check this. I also check this. Okay, alpha 1 is okay. Then what is the right hand side? Right hand side, as I already said, minus is already over, already out. Xb is 1 minus x. We must write this way. Beta 1 is there, plus beta 2. What xb should be written in terms of x. So what you are getting this side? 1 beta 1 here, minus, you check, beta 1 plus 2 beta 2 x minus beta plus beta 2 x square. This is, you have this. Okay, so you have actually 2 beta 2 x. One is this beta 2 x when multiplied by 1, and another is when beta 2 is multiplied by 1 but by x. 1 and x, the beta 2 x, 2 twice it will come, and beta 1 x. So you just check this, minus beta 1 plus beta 2 beta. Oh, I made a mistake somewhere where, you will have 1 beta 2 here, and when multiplied by 1 it is beta 2, so it is beta 1 plus beta 2. Beta 1 plus beta 2. Beta 1 plus beta 2 minus beta 1 plus 2 beta 2 plus beta 2 x square. Comparing coefficients, so constant term x and x square. We have what we have, constant term. What you get last time is okay. What you have, constant beta on right hand side, beta 1 plus beta 2 is a constant term, and the left hand side nothing, 0. And again x only x. You have alpha 1 left hand side, alpha 1 right hand side. What is x minus beta 1 plus plus 2 beta 2. Now you see beta 1 plus beta 2 is 0. Beta 1 plus 2 beta 2. So beta 1 plus beta 2 plus beta 2 means beta 2 is what? Minus beta 2 is minus beta 2. Okay, minus beta 2 and minus beta 2 right here or here also, or what? Right, everything you express in terms of beta 1. I said beta 1, everything expressed in terms of beta 1. I said on the real quantity, hypothetical values, everything. Okay, so here hypothetical, real quantity. Beta 2, what is minus beta 2? Right here, right? Or not only alphas, also all other betas, all betas other than beta 1, so expressed in terms of, of course, beta 0 cannot be. Let us follow. Or okay, beta 2 is minus beta 1. And now you say what is minus beta 2 is plus beta 1. Okay, so you have beta 2 express beta 1, alpha 1 express beta 1. Then what is the next one? X square. What is this connection? Alpha 2 is what? Beta 2. Oh, direct. Alpha 2 is beta 2. Alpha 2 is beta 2. Beta 2 is incidentally is what? Beta 2 is minus beta 1. So you see, we have expressed everything in terms of this. Okay, and last time from here also, and from 3, and from equation 3, and from equation 3, from equation 3 here, what is it, right? Alpha 0 plus alpha 1, right? Once more, alpha 1 plus half alpha 2 is 0. That is, or alpha 0 right this side, or alpha 0 plus alpha 1 what alpha 1, see alpha 1 is actually beta 1, everything in terms of alpha 0 plus beta 1, alpha 1, alpha 2 is beta minus beta 1, minus half beta 1 is 0, or alpha 0 is what minus half beta 1. So hmm, we have been able to express the coefficients which are these coefficients which are alpha 0 and what alpha 1, alpha 2, alpha 1, alpha 2 and what beta 2, and what is this beta 2, beta 2 in terms of beta 1 alone, in terms of beta 1, in terms of beta, putting these results in equation 1. Now you have got these results, just put it back in equation 1 and 2 and you have the result. Putting these results back into equation 1 first, equation 1, start equation 1. You write this ln gamma b is what beta 0, beta 0 is what, you write this beta 0, so already you have found this, what is, oh you have not found, beta 0 is not been, has not been expressed, beta 0 has not been, but beta 1 is beta 1, you have to everything expressed in terms of beta 1, so retain that beta 1, beta 2 is what minus beta 1, so minus half beta 1 xb square, okay, so what is this beta 0 minus half beta 1 common xb square minus 2xp. You check this first. Beta 0, what is it? Beta 0. And what is this here? I am taking common minus half beta 1. Then what it leaves? Xb square. And what it leaves? Minus half beta 1, it leaves 2xb. Minus half beta 1, I have taken common. So it is 2xb and minus 2xb. Minus 2xb. Then complete this as a square. I am adding 1. Plus 1 here means minus half beta 1 here. So plus half beta 1. This makes sense. That means what you have got is, repeat this, okay, minus half beta 1 plus half beta cancel, so it is returned to this value, is what beta 0 plus half beta 1 and half beta 1 minus half beta 1, what is this? This is 1 minus xb whole square, 1 minus xb square whole square, what is there? Is nothing but this is right, once more right, beta 0 plus half beta 1 minus half beta 1 x square. So let me check if this is correct, okay. What is this? X square, okay. Achha. Achha, let us, or you write it right here, right this side, or star this side, or ln gamma b is what? What is beta 0? Shall I have removed this? Actually, I have removed this beta 0. Remember what is the beta 0? Beta 0 was ln Recall this, actually I have removed this beta 0 was, beta 0 is also important. Beta 0 is what? Beta 0 was what? Beta 0 is nothing when xb is 0, xb is 0, ln xb is 0, ln gamma b is gamma b 0. Gamma b is gamma b 0, ln gamma b 0. So beta 0 is ln gamma b 0. I am writing here beta 0 is ln gamma b 0. This after you check back, that is there. I think I have removed this, okay. But anyway, beta ln gamma b. So write this, beta 0 is ln gamma b 0 okay. Okay. I told you 2 hours more. Beta 1 is what? Beta 1 I have already written for you, half EBB. Is okay, no problem. 10 minutes. Then check after 10 minutes. Half EBB, beta 1 is half BB minus half EBB x square. Take a look. Beta 0 is actually, remember, recall this, beta 0 is ln gamma b 0. So this, okay. Now does it not look like this? Compare this with oh here. Compare this with here, already there. Ln gamma b 0, ln gamma b 0 minus alpha. Instead of minus alpha plus EBB self interaction coefficient. Okay, minus alpha. And again you see alpha, again minus half EBB. X square. So this is actually, so compare this with the earlier modified regular solution. Equation, what is that? Equation for ln gamma b is what? Ln gamma b is what? Ln gamma b 0 minus alpha plus alpha x square. They are exactly the same. So start this place, double star. I remove this one. I don't want to disturb the top 2 lines. Remove this one. Okay. Here, double star. What is double star? What is this? So these two equations. So these two equations are identical, and we E alpha is what? Minus half E B B. Are identical, and we have the correlation. We are correlating the alpha factor and self interaction parameter. Alpha parameter and self interaction parameter. One coming from this is Margulis, this is coming from Maclaurin series expansion. So this so this is very important. This is the insight. What is alpha? Is actually interaction coefficient, and this interaction coefficient has physical significance and is to be experimentally found and will be utilized in problem solving and practical problems and other practical problems. So what is this? You just start this alpha. Alpha is what? You write regular solution. Recall regular solution. What? Coefficient. and this is what EBB cell EBB actually alpha cell interaction coefficient. Cell interaction coefficient obtained from Maclaurin's series expansion. Series expansion approach. Right, EBB, not half. Alpha and these are related. So the once you have reached here. So only one thing is left to show the first one, ln gamma A. This you will do now very quickly. Very quickly remove all these things. Ln gamma A is sorry. So this relationship I have removed this. Okay, no. Sorry. I should have not. Okay, I should have not. Anyway, I remember first. Ln gamma A. I am giving you. Next, what is right? In a similar manner, we can rewrite equation 1 as, in a similar manner, we can rewrite equation 1, this one, ln gamma b. What is this? What I have written? We have written so far ln gamma b. Equation 2. I'm sorry. Equation 2. This one, ln gamma, and I will reach here. Ln gamma 2, ln gamma a as could you write ln gamma a is what? Alpha 0 plus alpha 1 x plus half alpha 2 x square. These are all expressed in terms of beta 1. What is this? Recall this. What is this? Alpha 0 is what is this? Alpha 0 was what is the value of alpha 0? Alpha 0 was minus here minus half beta alpha 0. See alpha 0 is minus half beta 1. And recall what is alpha 1? Alpha 1 is beta 1. Recall this. Beta 1. Recall. I removed this. Alpha 1 is beta 1 x and alpha 2 is what? Alpha 2 is minus beta 1. Alpha 2 is minus beta 1. Half. Remove this. Okay. Remove all these things. Clear. So repeat, alpha 0 is minus half beta 1, alpha 1 is beta 1. You please check this, just a moment ago I wrote this. And alpha 2 is minus beta 1. Okay, very good. I have removed this. Okay. So what you will take common here quickly, minus half beta 1. Minus half beta 1, if you take common, you get what? X square. You get what? Minus 2x. You get what? Plus 1. What is this? Half, minus half beta 1. Remember, minus half beta is minus half beta 1. 1 minus x whole square is what? Minus half beta 1 xb square. And what is x? What is yes. What? Oh, sorry. It's okay. Minus half beta 1. What is this? Minus half beta 1 is what? What is this? Minus half beta 1 xb square is what? Minus beta 1 is what? Beta 1 is EBB. So please write this. Write along. Minus half EBB xb square. It's okay. Minus half EBB XB square, or ln gamma A is what? What? Apply this correlation. 5 minutes more. Apply this correlation. Half minus half EBB, half EB is alpha. So alpha, right? Alpha XB square. Here return to this. Both are returned. Only remember they are same. Alpha is minus half EB. Alpha of regular solution, alpha parameter of regular solution is here minus half EBB. EBB is the self interaction parameter. This is the. So we have actually got the same relation, but in a different way or using different technique, different equations. Source equation is different, Maclaurin series. Okay, so this is ln gamma. So few comments here. So just here. This is also the same modified regular solution, relation as right here. Note alpha is, note here once more right here. Note alpha is minus half EBB. Although written here, but once more you may write here, so that from here, how will getting here? You are getting here. Getting here means here. So this I am writing. This is also the same relation, modified regular solution relation as obtained before. Lastly, summary. I am giving the just summary. What time? 2 minutes, another 5 minutes, 6 minutes, 6 minutes. Summary, 5 minutes or 6 minutes. Summary is what? This summary will be important. So, how much of discussion? Modified summary I am giving on the top. I think this line is not required. This line is not required. So here I am writing summary. Summary. What is the summary? Modified regular relation solution relation I am talking so much on modified regular solution because this will be used in our subsequent discussion. Regular solution not so much. The modified form will be used more than the regular solution directly itself. No, modified will be used because of its practicality. Okay, modified regular solution relations when what is the relation when the ln gamma I versus 1 minus xi relation does not multiple regular solution relations are applicable. are obtained are obtained are obtained are obtained when the ln gamma I versus 1 minus xi relation does not does not does not hold good does not hold good over the entire composition entire composition of the AB solution. The solution AB. What does this? What does this write nicely? Alpha is minus half EBB is written here. I have written here. Alpha is minus half. I am removing this. This is here. This is here. So I am removing this just to finish this. So what is this all written? Modified regular solution relations are obtained when the ln gamma I versus composition relations does not hold good over the entire composition of the solution AB. Means it is actually up to a limited concentration of the solute. So then what are the results? Results is this. I am summary. Summary means I am giving the result once more. Ln gamma A, you write nicely. Ln gamma A is alpha xp square is minus half EBB xp square. Give a name to this equation 3. And what about the B? B is what? You know, as I am writing this, you see, take a look. I am writing this. Then I am casting in the form of interaction coefficient. Maclaurin. So here also write ln gamma B. Ln gamma B is what? Ln gamma B0 minus alpha. I am writing this, copying this, plus alpha x square. And then substitute alpha is, okay, right, proceed. Ln gamma B0 gamma B0 plus alpha in common x square minus 1, no problem. What is this? Is ln gamma B0, what is xa? 1 minus xb. 1 minus xb means xa is 1 minus xb, then what you get? 1 minus 2xb plus xb square, 1 minus 2xb plus xb square, 1 minus 2xb plus xb square minus 1. So 1 minus 1, 1 plus 1 minus 1 cancel, giving this. So this is what? This is the last line. Ln gamma, this is what? Ln gamma B0. What is your alpha? Plus alpha minus 2xp plus xp square I have written is plus EBB. Alpha is minus half EBB. Remember, alpha is minus half EBB. So minus half I am consuming here in the parenthesis. So minus half and this plus xb and minus half xb square. Take a look. Perfect. Call it equation 4. 4. 4 or 5. Okay. This is the how this cannot be 3. 3 already there. So this is your 4. This is your 5. Oh, x is 1 minus x. Right here, x is 1 minus x. No problem. So this is your 5. So this is your summary. Quickly, ln gamma a alpha x p square. Alpha is what? Minus half AB. Interaction coefficient coming from Maclaurin's. This approach. This. And ln gamma b is this. Modified regular. Then this actually you have some juggling x square minus 1 cast in terms of xb, and you have alpha is minus half EBB substituting. You are getting ln gamma b 0 plus EBB times xb minus half xb square 4. So with this we have completed this derivation also, alternative derivation over. This alternative derivation is also over. Okay, so we'll take up actually some assignment problem next class. I mean assignment 9. Okay, and also some other discussion like multi-component system. Okay, what is the activity coefficient versus composition.